Every single day, there are robots moving, and every single day, they're doing crazy things in our office. And it's so cool to be able to see that just day in and day out. I'm Paul DeMonico. I'm a robotics engineer on the Spot locomotion team. We're a team of roboticists and software engineers, and we're responsible for making Spot move essentially anywhere in the world. Boston Dynamics has been doing legged robotics for decades now, and that's largely based on our ability to understand and our ability to model these robots. Really, model predictive control is at the root of how we have been able to get as far as we have. If you look at legged locomotion, here at Boston Dynamics, we have a really good understanding of rigid body dynamics. We have great models that we can run very quickly and that we think are very accurate for how the robot will, in fact, move in reality. But there are parts of the problem that are very hard to solve. They're very hard to model, or they're very hard to model efficiently so that you can run it in real-time control. Something like how the robot's going to move its leg, we understand the dynamics of that leg and how we should move it. But let's say how the robot should step through the world. There's a bunch of ways that the robot could sequence its leg. How long should it swing that leg? How long should it hold the leg in contact? Where in the world should the robot step? It's this very high-dimensional space, and these are problems where, as engineers, as scientists, it's really hard to come up with a good solution. Now with reinforcement learning, as long as we're able to simulate these hard problems, there's a class of problems that we should be able to tackle. Reinforcement learning is a subfield of machine learning. At the heart of reinforcement learning is data. It's generating data that basically explains how the model interacts with the environment, and then be using that data to train an agent. In reinforcement learning, our model is an agent, and it's going to learn through its experiences in whatever environment we put it in. Reinforcement learning for robotics that's largely in simulation. So an agent experiences things a robot would in simulation, and the reinforcement learning algorithm is going to do two things. One, it's going to explore a range of possible solutions that the robot could have in that environment, and it's also going to try to find the optimal solution. What is the best way that robot should interact with the environment? One of the main things we're trying to do now is we're trying to find this balance of when can we use model predictive control, when we have models that we think work well for the problem we have, and then when can we use reinforcement learning when the models may be perhaps too hard to run hundreds of times a second or just very difficult to actually write. So we're trying to find this hybrid approach where we have a system that we've written the models for, and then we have a system we've generated the data that describes. And we're trying to train systems that will then perform an optimal action based on that data and interplay with our models. And we think that that is going to give us the best performance for spot locomotion right now. We've seen some really exciting results using machine learning, and specifically using machine learning in this hybrid approach where we're taking advantage of the controllers that work really well for us now and replacing some of the hard parts of the problems. So something like when the robot is slipping or determining where to step, there's a lot of split-second decisions that the robot needs to make. If it's slipping and the piece slide out from the robot, it's generally a good thing for the robot to step as fast as possible and to recover. But if you imagine the robot stepping down or stepping up or stepping over something, you can't necessarily step just as fast as possible because you need to be able to get the foot to a good location. The robot's able to take quick steps when it needs to, but also really be careful and intentional about stepping over things, stepping in good locations. And it seems to be able to balance these solutions in ways that we were better than writing ourselves. With our latest software release, every customer, every user of a Spot robot is immediately going to get access to the benefits of these new algorithms, because this is now the default behavior for all Spot locomotion. Whenever you're using a Spot, there is now going to be updating a neural network hundreds of times a second, which is going to be impacting the control system, and it's going to make it more reliable and more capable to traverse a wide set of environments. There's a saying in robotics that there's no such thing as a good model, there's only useful ones. So no model is entirely accurate, and if things become too complex or we want to do totally new behaviors that we don't know how to write ourselves, we think we can use the data and use reinforcement learning to enable new capabilities. on Spot, but also all our robots. And not just locomotion, things like manipulation, being dexterous and agile in the world we exist in as humans is going to be more capable using these algorithms.